Unit 1 test review. Here we go. Use the following graph for questions 1 through 7. So this is the graph, 1 through 7 right here. Question number 1, basically saying, hey, look at this graph. What's the domain? Remember, the domain is essentially saying how far left does this go? And be careful to pay attention to whether or not it's a parentheses. That means it doesn't quite get there. Or a bracket. That means it includes it. And then how far to the right. And the same thing goes with the parentheses or bracket. So how far left does this go? Remember, the temptation is to think range or up because of that arrow. But think wide. As this thing goes up, how wide does it get? Well, because of that arrow, it means it never stops, which means it's going to continue getting wide forever. So it's parentheses, negative infinity, and then how far to the right will this graph go? Same thing holds true there. Never stops. It continues getting wider and wider and wider as you go out. The x values just continue going and going and going. All right, what's the range? Well, this is asking how low does it go? And then how high? Well, this one clearly is another word for it is minimum. And so how low does it go? Well, it goes -3. And that's my y value. So don't forget, I'm not worried about my x value. That's left and right. This is my y value up and down. We start with how low it goes, and because it's filled in, it's going to be a bracket, -3. How high does this graph go? Well, it continues going up and up and up and up and up and up and up forever and ever, amen. So there it is. X-intercepts, pretty simple. Where does this graph cross the x-axis right there? -5, 0. There's the reason for this little s, because this one has 2. Or and, -1, 0. What about the y-intercepts? Well, as I cross the y, if I look at the y-axis, crosses it right there. I know my drawing's a little bit weird, but 0, 1. Not trying to trick you here with decimals or anything, just trying to get the definition right. Okay, where's the interval or intervals where the graph is positive? Remember, positive means above the x-axis. And as you notice, let's see here, I got a highlighter, give me a second. The portions of the graph where it's positive, we're going to make orange. And that's here and here. So don't forget, positive means strictly above. The tricky part is that does not include this point, and it does not include that point. So where's the interval where the graph is above the x-axis? Well, it's only this portion. So I'm going to talk in terms of how wide does it go that way. Negative infinity, all the way up to -5, but it does not include -5, hence the parentheses. You got to pay very careful attention to the parentheses. But then there's a second section. And again, we're moving left to right to explain the interval. Starts at -1, but it doesn't include -1. So we're going to use parentheses again. And then it just continues going up and up and up and up as far as it goes to the right. This is kind of a domain question. So that is infinity. All right, another type of definition. Where are the intervals where the graph is increasing? Remember, the key to increasing or decreasing is to think roller coaster ride left to right. If you're on a roller coaster ride starting on the left, and we want to find out where the graph increases, that simply means goes up. Well, clearly we'd be going down, screaming our heads off, but then at this point, you can see that it starts increasing. So from this point, -3, I'm just going to put a bracket around it. I know we could argue about that because does it include it? Well, I'm going to say yes because that's where it starts. And then it goes up forever. And that's where it's increasing. Now, rate of change, is another way of just saying slope. So if you have your slope formula handy dandy, you could use it, or you could just go old-fashioned rise over run from this x value to this x value. So this is a different way of just saying, what's the point where x is -3? That would be this point. So where's the point where x is -1? That would be this point. So they're saying find the rate of change between these 2 points. It's just a different way of delivering the same question. So maybe you would want to just go rise. Now if this is 3 below the x-axis, then it goes up. Remember, up is positive, 3 units. And then to the right, 2. And remember, right is also positive. So that would be 3/2. If you wanted to use the other method, this would be x1, y1. This is x2, y2. Plug things in where they belong. 2 minus a -3. Already screwed that up. Y sub 2 is 0. Don't know where my mind went there. All over x sub 2 is -1 minus a -3. A lot of negatives here, but this is 0 plus 3, which is 3. 2 negatives make a positive. And this is -1 plus 3, which is 2. Okay, if they just give you the drawing like this and it's easy to count, you can just calculate rise over run. All right, let's go on to number 8. Number 8 says, for number 8 and 9 actually, graph the transformations without decimals. You're on your honor there. So, if we remember our rules, y equals a dx plus c plus d. We notice our a is just a normal 1, no big deal there. B is a 1, no change there. X plus 3, that's our c. Plus 3 is going to mean left 3, and there is no d. So all we have to do is take the parent function, which is y equals x, y equals the absolute value of x. And remember that that is a v, and make the adjustments. So we take that guy, that's our parent function, move it left 3, 1, 2, 3, and do our best to redraw it. And that's it. That'd be my f of x. Doesn't need to be perfect. Just get it in the ballpark. Get close. Okay, so we look at this guy and we say, hey, what's the parent function? The parent function for this one would be y equals x squared. We got to know what this looks like before we can make the adjustments to this. So it's not perfect, but it would look something like that. Good old parabola or quadratic. One step at a time. What does that do? Reflects it over the x. Dotted. What does that do? That's going to vertically stretch it, make it skinnier. So I'm going to go like this. And what does that do? Well, it moves that last one that I drew in there, right 1. And now I can try to duplicate this. I'll make it all pretty. And there'd be my final answer. It's a good idea on these sort of questions to say, like, there's my final answer, so I can tell. Okay. All right, so this is the language of transformations, because it says, use your understanding of this general equation to describe the adjustments made to the parent function. So I gave you a little hint: compress, stretch, shift. Does it go up or down? Does it reflect over the x or the y? Things to keep in mind. So as you can see, there's no negative in the a, so we're not going to reflect it over the x, but this is a fraction, so we know that it's going to be compressed by 1/2. This right here, hopefully you've been listening, is going to move the parent function right 2. And this is my letter D, so that's going to go up 1. That's it. Let's go on to number 11. As you can see, my A is negative, so that is where we're going to reflect over the x-axis. There's going to be a vertical stretch by 4, and we're going to move left 2. Next one. Okay, number 12. You can see that our A is 1. There's no reflection over the x-axis, and there's no stretch, no compression. B is negative 1. That means we're going to reflect over the y-axis, and then negative 1 is going to mean we're going to go right 1. Okay, number 13, graphing the following piecewise functions. Okay, so piece by piece, and that means only concentrate on this domain for that function. So we're going to take f of x equals x squared plus 4. What I'm going to do, and yeah, you could mess around with decimals, but I'm going to take the outside limits of my domain, 0 and 2, find out where they go. I know this is a parabola. I can look at it, y equals x squared with a bump up 4. But this is the window that we are to concentrate on. So if I plug 0 in here, 0 squared plus 4 is 0. 0 squared 0 plus 4 is 4. So there's my first point, 1, 2, 3, 4. And then I'm going to pop in 2. 2 squared is 4. 4 plus 4 is 8. And so I go out 2. 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8. And I know if I was to continue graphing this, it would continue up, 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 up like a parabola, and it would go this way as well. But that's telling you, nope, only concentrate on that little window. Do the same thing here for this linear equation. You can see it's linear because it's a highest power of 1. A little different domain here, saying, all right, negative 2 to 0. So I'm going to start with that and that. So plug them in. Negative 2 times 2 is negative 4, plus 4 is 0. Negative 2, 0. And if I plug 0 in, 2 times 0, 0. 0 plus 4 is 4. So you can see this is a line, linear equation. This is supposed to be straight. This is supposed to have a little curve on it. Hard to kind of make that happen for this problem. So there's the graph. Now let's answer some questions. What is the range of this function or this graph? The range means how low does it go? Well, it gets, remember, it's how low does it go and how high does it get? Well, it gets to 0. So we got to use a bracket, 0. How high does it get? Gets to 8. That's our highest value for y. On what interval is f of x increasing? So if we were thinking, okay, roller coaster, I'm not going to draw the cart, but we start on the far left, start on the left and move right. So you got to move left to right on these. You would be going up, 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 up the whole way. So the interval would be x value, that's negative 2, 0. This point here was 2, 8. Again, we're talking domain from negative 2 to 2. It would be increasing. 30 seconds left for these last three. Are the following sequences arithmetic? If so, what's the common difference? Well, you can see 6 plus 7 is 13. 13 plus 7 is 20. 20 plus 7 is 27. Yes, and because it's going up, common difference would be 7. This would be plus 4 plus 5, and that would be plus 6. You can see this is a no. Better save the last one for part